Dino here. I want to talk about function calling, or what Gemini calls function calling. And in the scope of large language models, what that means is um, Gemini supports the idea of telling an application, hey, I want you to invoke this function for me, and then send back the response you get. Now that's going to help me generate a response to the user prompt. So Gemini calls that function calling. And it's documented here. This is introduced a long while ago. There's some good, interesting details in the documentation. The reason this is, I find interesting and valuable to go through is because it relates to MCP. It kind of gives you some background for how to think about MCP. I put this repository together a long while ago, and since I shared the repo, Anthropic introduced MCP, and Google published the Agent Development Kit, and so there's a bunch of activity around this, but I still think this repo is valuable to kind of clarify the fundamentals and the underlying interactions between the agent, the LLM, and potentially any tools the agent has available to it. By the way, what Gemini calls function calling is referred to as tool use by Anthropic. Very parallel capability. So Anthropic is or the Claude models provided by Anthropic are very similar in concept to the Gemini models provided by Google, and they both have a kind of a parallel capability, which is this tool use or function calling. So let's get into some detail. So what's the reason behind the need for function calling? LLMs are they seem magical, but they're constrained. They're trained on a specific data set, and they can't query or modify external data. And that's not 100% true at this point. Gemini, for example, on the server side, can augment its training data with data that comes from Google search. So if you ask Gemini UI, can you tell me the weather in Des Moines, Iowa? It's going to be able to respond with current up-to-date weather information, despite the fact that it was trained on data that's old. Or something like, are the Seattle Mariners playing tonight? And if so, which team? Gemini is going to be able to answer that because it has that search capability on the server side. So it is frozen, but it has a few tools, generally accessing public data. The remote Gemini model, though, obviously cannot plug into systems that are local to your environment or tools that are specific to you, and function calling is intended to mitigate that limitation. So the way it works is a user sends a prompt into an application. The application sends that prompt over to the model. What we're talking about here is Gemini, like Gemini Flash 2.5 or something. In the case where the application has functions available to it, it also sends the function information to Gemini. It says, what do you think? Tell me how you would like to respond. If Gemini believes that or judges that a correct and complete response to the user prompt would require extra information, and that information could be provided by functions that are available in the application, Gemini will send back a response to the application saying, okay, I can't give you an answer just yet, but I want you to invoke these functions or this function, one or more functions. The application is then responsible for invoking that function, which may be local or it may be remote, and collecting the response and then sending the original prompt plus the response from its function to Gemini. And in the simple case, Gemini says, okay, given the prompt and the extra data that you sent me, that you obtained from that function, here's my response that you can send back to the user. So that's function calling. And this repository is a couple of fairly simple Python scripts that kind of exercise that. Actually, the first one is super simple. It just invokes the Gemini API. So if you're not familiar with the Gemini API, it's available at generativelanguage.google apis.com. If the only way that you've interacted with Gemini is via the UI, via something like this, then maybe you don't know about the API. There is a programmatic API that you can invoke, and this Python script that I've written shows you how you can exercise that. That's the first one. The second one actually uses tools, and it registers a few tools, has a few local functions in the Python app that it can invoke, and it tells Gemini about those functions when it sends in the prompt. And then Gemini will be able to see Gemini sending back a response that says, "Okay, app, you have those functions available. I want you to invoke them." So for those of you who like to see what API calls look like, this is a simple API call to the Gemini model that asks it to generate content. So if you go to AI Studio, that is AI.studio, you should be able to register an API key. You'll be able to sign in and register an API key, and you'll be able to invoke APIs yourself like this. So that's basically what we're doing, but we're doing it from within Python in this repo. And the JSON payload for a prompt would be something like this. Okay, what are some good approaches to improving my sleep quality? This is a prompt that Gemini would be really good at being able to respond to without any external tools. No need to invoke external tools, but that's an example of how you would pass it in. Now, if you have tools available, you could augment that payload, and it gets a little more complicated. You pass in an array of tools, your application does, and each tool is described this way, which is to say the name of the tool, the kinds of parameters, the number and kind of parameters that it accepts, and its purpose, what it does. All of that is really important for Gemini to be able to assess, hey, if I want to generate an answer to this, is this tool going to be helpful to me or not? I use the example here for generating or assessing Scrabble word scores, thinking, okay, that's a novel thing that Gemini doesn't actually know how to do, but it's actually smart enough to figure that out too now. But beside the point, we're trying to illustrate tools here, so that's the purpose. When you send a request like that with tools to Gemini, you can get a response like the following back. And it'll have content, and rather than text content that says, okay, here's your answer, it'll have content that says, here's a function call I want you to invoke, and here are the arguments. And then it's incumbent upon the application to invoke that function call. And then once the application gets the response from that function call, it has to send back the original prompt, Gemini's instruction to call a tool, and then the result from that tool call. Has to send all that back in the subsequent payload back to the model, back to Gemini. So here's the original user prompt, here's what Gemini asked for, and here is the result of or here's the set of tools that are available, and then there's the actual response of the tool. Gemini then assembles and digests all of that information and provides back, a coherent response, a complete response. And you can actually iterate. So Gemini may send back another response that says, okay, got that function information. Here's another function I want you to invoke. So it may iterate a few times. This is an actual practical illustration. This repo contains a practical illustration of how that's going to work. And I want to show you the Python code. So even if you're not a Python expert, you should be able to sort of understand what's going on here. This is the first one, the first illustration, and it does not use tools. It just shows you how to invoke the generative language API from within Python. So that's the API, and there's got to be, this one is actually just fetching the model. So you can ask Gemini, what models do you have? This one actually invokes the request to generate content, and it picks one of these prompts, and sends it up to Gemini, and then gets a response, and then emits some information on the terminal that actually shows you what it was doing. So I could do something like Python and that thing, and it'll tell me what it's doing and the requests and responses that it's getting back. So this is the response that says, tell me all the models you have. And there's Gemma and Gemini, Gemini Flash, Gemini Pro, and all those different models. So it's just telling us, that's just an example of how you can list all the different models. This one says, if I am visiting Seattle in June, should I rent a car? Would it be better to use public transit and use Uber and Lyft? And then we get the full response. So not so interesting. That part is not so interesting. The main point is I just wanted to show you what it would look like to invoke and the Gemini API and get the response back. Okay, so that's the first example. What we really are interested in maybe is the one that invokes tools. So before I show you it operating, I want to show you how it's defined. And this is a little more involved. It doesn't just send an API request and print the response. It has to do that iterative thing. It has to get the response, look at it, see if there's if there's a request to call a function, and if so, do that. Invoke that function. So this is basically a loop that's doing that in Python. It makes the first API call request, and initially this API request is just going to use the prompt. So it's going to use something like that original bare, okay, here's my prompt that I got from the user, and here's the list of tools I have available. Then it has to extract the function calls from the response. What do you want me to call? What does Gemini want this program to invoke? What functions? And if there are functions, then it needs to go invoke those, assemble the response, and then loop around and send the next request. After there's no more extracted requests for function calls, then you have your final response, and then this program will just print that. So let's see it work. We'll flip back over to the terminal. We'll run that. Let me run a particular version that requests weather. Okay, so and this is going to show a lot of text, which you're not going to be able to follow, but I want to scroll all the way up, and I'm going to show you what it sent. So my request was that it sent was, will it be cooler in Louisville, Kentucky, or Seattle, Washington tonight? That's the request payload, and or that's the user prompt. The full payload looks like this. It has the user prompt, that part, and then a list of tools that it has available. And the list of tools, there's exactly one. It's this get weather forecast tool. So this is what we're sending up to Gemini, the model. The model then sends back a response. This is what it looks like. Function call. That says that is Gemini telling my app, I want you to invoke that function. And here's another one, function call. I want you to invoke the same function. First, I want you to invoke it with this argument. Then I want you to invoke it with that argument. And that is the response that Gemini sends back to me. Once the app gets that, it goes and invokes those functions. And this is just some diagnostic information that the function calls are getting for that get weather forecast. So it's getting the forecast for Louisville and for Seattle, and then the app sends back the original request payload, the response data from the first request where Gemini was sending the app, I want you to call those functions. So we send that back to, hey Gemini, remember you sent me this. And then finally the responses from the function calls. So first the weather forecast for Louisville, and then there's, I don't know, a bunch of different days. Then the weather forecast for Seattle and all the data for different days. And then followed up with, don't forget, I have these tools available to me if you need any more information. So all of that goes up into a big payload that gets sent to Gemini. Finally, the model comes back with a succinct response. It will be cooler in Louisville tonight with a low of 55 degrees Fahrenheit. Seattle's going to be 61, and that's it. So the iteration ends. There was really only one there. That is how function calling works with large language model. It's not exactly the same in Anthropic with Claude Sonnet or Claude Opus, but very similar. The payloads for those guys will look slightly different. So how does this relate to MCP? Well, MCP describes a proposed standard for how chatbots or agents can get and understand tools, available tools, and invoke them. So we saw in the diagram above, there are three actors. I'll show it down here. There's the application, there's the model, the application or the agent, let's call it, or the model. That could be something like Gemini or Anthropic, Claude, Sonnet. And then the third thing is maybe tools. And in my case, in this example here in the repo, the functions are all local. They're all defined within the application. So they're just locally linked and defined in that Python script. You could do the same thing with Java or JavaScript or C# or whatever you want. They could be local. What MCP is it describes how a tool server might advertise tools that are available to an application via a standard. So MCP fits right here. And the application can say, okay, what MCP servers are out there, and it can query them. Okay, MCP servers, what functions or tools do you have available? It gets that list and sends that list of tools to the model with its prompt. And when the model sends back this reply saying, oh, I want you to invoke these tools, then again, MCP describes how the application might invoke that, what that might look like for a remote invocation. So really, MCP is a way to describe the interaction between the application and a separated tool server. It does not describe how the application interacts with the model. So MCP is strictly about the application connecting to tool servers, and this dialogue between the application and the model is not affected by MCP. It's informed by perhaps the tools that are advertised in MCP. So what I mean to say is the thing in the tools array in that JSON payload, the things there will be obtained from the MCP server here, but that tools array still is sort of dependent upon and dictated by the specific model, Gemini or Claude Sonnet or some other model, and it'll be different. There's no standard specifying that. So this is something that you can try yourself and you can fiddle around with. It does not use MCP, but I think it's a good illustration for where MCP fits, what function calling is, how models interact with agents. It kind of gets you familiar with how all these different pieces fit together. And for that reason, I hope it's valuable and instructive. Till next time, keep it digital.